All right, our amplitude is 1. Now we're actually going to have to do something with this 2 pi over b. Okay, so b is whatever is in front of x. So in this case, it's 2 pi over 1/2. So just divide 2 pi by 1/2, which, no, when you divide by a half, it's like multiplying by 2, so it is 4 pi.
That'll work on a calculator, right?
Yes.
How do we get 4 pi?
2 pi divided by 1/2.
How does that make it 4? Why is it not making it?
Because 2 pi divided by 1/2, you flip and multiply, remember? Division with fractions. Yeah. Yes, Sam.
So like you really don't have to do anything with that though, do you, since the graphs are already made?
Right, so that's really, it's helpful that the graphs are made because that's going to tell you, now this is where our x values are going to be different, the numbers we plug in. Right, so for these, you really need to look at these graphs so you can see what we're plugging in. So look, this one goes up in increments of pi. So we have 0, pi, 2 pi, 3 pi, 4 pi. So that's going to be what we plug in for x. I'm going to do my chart over here.
Oh, so like at the end of the chart, that's what it will be?
Yeah.
Okay.
All right, so, what? Okay. So I'm going to add another row to my chart this time. Because, look, we're doing sine of 1/2 x. Since the 1/2 is here, we have to multiply the x before we find our sine or cosine. Okay, so I'm going to have a column for x, a column for 1/2 x, and then sine of 1/2 x. Why is my pencil so glitchy? So, again, we're plugging in 0, pi, 2 pi, 3 pi, and 4 pi.
Oh. Oh, is there not saying it's 1 pi?
1 pi and pi are the same thing. Doesn't matter.
So these, okay.
Okay, so now the next step to make it easier on yourself is why I put that other column there, right? So now we're going to take all those x values and go ahead and multiply them by 1/2. Then you can just find the sine. That way you don't have to think about like multiplying and finding the sine in your brain at one time. Okay, so 0 times 1/2 is still 0, right? So 1/2 of pi is just pi over 2. Half of 2 pi is just pi. Half of 3 is 3 pi over 2. And then 2 pi. Yes.
Where can we see these?
What do you mean?
Like how do we know what we're getting?
Because I took x and I multiplied by 1/2. So 0 times 1/2 is 0. Pi times 1/2 is pi over 2. 2 pi times 1/2 is pi. 3 pi times 1/2 is 3 pi over 2. 4 pi times 1/2 is 2 pi. So now, yes, Daniel, this looks like our normal list. Right? But, so now we're going to plug these values in and find the sine, because we know 1/2 x, so now we just need to know the sine at 0. Looking at our unit circle is, sine at pi over 2 is, sine at 2 pi,
0.
or I'm sorry, at pi is 0 still. 3 pi over 2 is -1, 0. So, the part that really makes it different is that the numbers you have on this x-axis, right? We're scaling our graph differently. So now, like, we're plugging in, like, 0. Look. So, like, at 0, we have 0. At pi, we have 1. At 2 pi, 0. 3 pi, -1. 4 pi, 0. So this one's going to look really similar to what we did yesterday, except the period is longer. Yeah.
So you do like the 1, 2, 3, 4 pi thing every time?
No. So, like, for number 9, we're going to look at, so, like, look. So, for this one, we only have pi. So we've got something a little bit different here.
So like 1/3 pi, 2/3 pi.
Yeah.
pi.
What?
So pi over 3, 2 pi over 3, pi. All right, that's why we're going to do number 9 together. All right, questions on 7? Okay. Can I just like, all right, that goes with 7. All right, so now let's look at number 9. What is our amplitude for number 9? 2. It's always positive. We don't worry about the negative signs. Oh my gosh. All right, so now to find 2 pi over b, what are we dividing 2 pi by? 3. So it is 2 pi over 3. Plug this in for a second. Because it's always 2 pi divided by the number in front of x. Yep.
Wait, so I have a question. I know this doesn't have to do with math, but tomorrow's the chicken noodle soup stuff. Alright. Well, I won't make it, but
What are you making?
Chicken noodle.
I love
Let's
it.
go.
thank goodness. That's the only thing I like.
Yeah, it's like homemade chicken noodle.
What time are we eating at?
Oh, yeah.
Like noon.
Okay, so we got one. That's like the only thing I
Your
like.
chance to avoid the mess.
I know.
What?
Really, what that means is like your function, like by the time you hit 2 pi over 3, it's going to do that, like your up and down thing.
So it doesn't, we don't really have to focus on that.
No. You kind of use that to determine this, but where these graphs kind of give you that hint there. Okay, so here we have, look, so this is, like Briar said, this is pi over 3. What is wrong with my pencil?
You have to change the all the things like one more.
Yeah, I just changed it like a couple weeks ago for the first time in like 5 years.
It should be working.
I know, but it's not. All right, that's better. Okay, so we have this. So basically what's going to happen is we're going to plug in. All right, so again, we're going to do x. We're going to do 3x. And then negative 2 sine 3x. So for x,
Wouldn't it be 0, 1 pi over 3, 2 pi over 3, and pi?
yeah, although we're going to need to get some more stuff for this one. It's a little tricky, yes.
How come on this one you added the minus 2?
Because it's on the outside.
We didn't do that on the last one.
Because there wasn't anything on the last outside.
Okay, so if there's something on there, we add it.
Yeah. Yes, Sam.
Can you real quick zoom in on the bottom 2 red things?
Yeah. All right. But here, let me try a different color.
I still can't do that.
Better?
Yeah.
All right. So that's not going to give us enough. Because look, so our period is 2 pi over 3. So that means our function is going to go up and down and back up by the time we get to 2 pi over 3. So we need to have some stuff in the middle.
Wait, so how do you know to do that?
All right. Again, the period tells you that by the time we get to 2 pi over 3, our graph is going to have to go up, down, and back. So like if we just plug in here, so if we just plug in 0 pi over 3, 2 pi over 3, all we're going to get is this, and that's not enough to graph, right?
Oh, okay.
It's straight line.
Right. So now we need to like get some part waypoints here.
I'm gonna forget where to do that.
Yeah, what?
So,
Well, I mean, if
Thank
we
you.
work it out and it looks like that, we'll know.
right.
I guess.
So, sorry. That one's going to need to be pi over 6. This one is pi over 2. And if you need help figuring out what they are, I will help you do that.
Alright.
Do we need to do another pi
No. Because our function's only really going to go to here. Like, so, in our chart, we're going to have 0, pi over 6, pi over 3, pi over 2, 2 pi over 3. All right, so then when we multiply those by 3, 3 times 0 is 0. 3 times pi over 6 is pi over 2. 3 times pi over 3 is pi. 3 times pi over 2 is 3 pi over 2. And 2 pi over 3 times 3 is 2 pi. So again, the goal is by the time you need to like pick stuff here that when you multiply it, you're going to get this basic list.
So that's what the middle is. Get the
That's the
basic.
same as the other one.
Right, that's what we
The
want.
goal is to get the basic list. So you can tell by the numbers on here.
Yes. I mean, these numbers are on there also, but it's easier because you have to multiply by 3 anyway. All right, so now sine at 0 is times negative 2 is 0. Okay, the sine at pi over 2 is 1 times negative 2.
What are we talking about? Where are we at?
All right, Zane, I'm taking this, plugging it in here. So we're finding the sine at pi over 2, then multiplying it by this negative 2. We're using the unit circle.
Okay, oh.
So from your middle list, now that you've multiplied by 3, you're finding the sine at each of these values, then multiplying by negative 2. All right, so sine at pi is sine at 3 pi over 2. Well, yes, but it's technically negative 1 times negative 2 is 2. And then 0.
I said the 3 has nothing to do with this.
We already took care of the 3 in this part.
Okay. Is that okay if we don't write the trigs? Because that's done now.
What about
Yeah, you just have to remember that you're multiplying each of these by 3 before you plug them into
I
sine.
know, it's just the
pi?
last
Why-
one where it has to
why
be
is
something that's like messed me up because I feel like I have to do something with it.
why isn't pi on the list?
So wait, do you see it
Yeah.
when you're doing the graph?
Because we don't need it.
You don't
So
know
you don't
that.
have to.
Because we only have to go through 2 pi over 3.
When you're doing the graph, do you do the little point on the small dashes too?
Yes. Right, so like we have 0, 0. Then at pi over 6, it's negative 2. So we're going down here. At pi over 3, we're back at 0. At pi over 2, we're up here at 2. And then here. So this one is like really narrow.
Yeah, that's so narrow.
I'm just confused how you know when to do the small dashes.
Well, I'm going to go ahead and tell you when to put them in and what they should be. That way you guys have that list. All right, so I'm going to put the whole worksheet up here. I'm going to like fill in the small dashes for you guys if you need them, like on the problems. That way you know, like you can look up here and know. Okay?
Wait, is that 3 pi over 8 on 12?
Yeah. So it's pi over 8, pi over 4, 3 pi over 8, pi over 2. Hold on. All right, your chart for number 8. So your x values that you have are going to be 0, 3 pi over 4, 3 pi over 2.
Why don't you put in a pi there?
Because it's going to give you a weird value that you don't need. All right. And 3 pi. Now, then remember you're multiplying those by 2/3. And then taking the cosine.
Well, what about 2 pi?
All right, those are the only ones you need. I promise.
Where did the 3 pi over 2 come from?
It came from here. That's the middle, yeah.
Look at all this. Plug in this.
Yeah, basically plug in those and then you got it for number 8. The rest of them are nice and neat on the graph and self-explanatory. Okay?
This one was the one that kind of.
I forgot. Oh yeah. What do I do now?